Okay, I'm going to walk through this homework problem using a template from example 12.1, Fancy Windows from the textbook. So I'm going to basically use this template for this problem. I'm going to rename this Homework Precision Furniture based on this problem here for the homework. What we have is we have three different products, and the question is, how many products should we produce? How many chairs should we produce? How many desks should we produce? How many storage units should we produce in the aggregate, each one of those, right? As categories, product categories, total number of chairs, total number of desks, total number of storage units. That is the question. And the way we're going to answer this question is by maximizing our total profit. So that's where this is our objective function value cell. This is the um, objective we're going to use to maximize our profit using the input of how many we should make, using the sum product of how many we should make, and the profit for each one of those. So we need to put in a whole bunch of information here in the blue as kind of inputs into this problem. And need to make sure we check our formulas here. We'll go ahead and put it all into solver, and then we'll run it, and we'll see if we can't get a maximum profit. So why don't we go ahead and start with the selling price and production costs for each one of these three products. So we have down here, we have the production cost of the chair, and we have the selling price of the chair. So the selling price of the chair is $180. The production cost is $120. So that means the profit is going to be 60, net profit per unit. In terms of desks, the selling price is $350, the production cost is $250. In terms of the storage unit, this modular storage unit, selling price is $140, production cost is $90. So now we have our profits. Let's figure out the hours. What are the total hours in the three different resources? So let's put our resources in here. This is the wood processing plant. And for each time, each hour that a worker puts into the chair in the wood processing plant is 0. What does that mean? Basically, that means the chairs are not being produced in the wood processing plant, but they are produced in the metal fabrication plant and the assembly plant. So we can put those hours in here as well for the chair. Let's do this. Let's add in our resource names first so we can keep track of what is what. This is our metal fabrication plant, and this is our assembly plant. And in the bottom here, we'll go ahead and put in here chairs. This is our chair demand. This is going to be our executive desk demand. And this is going to be our modular storage unit demand. And again, I'm just changing these names based on kind of a template from that first example in the textbook 12.1. Okay, now that we have our resources renamed here, our constraints, or have our plants renamed, and we have our demand renamed, let's go ahead and continue to put in this information here. So we know for the chair, if I wanted to be really specific, I could be chair, desk, and storage unit. And so for the chair, there's 0 time going into the chair at the wood processing plant. There's 0.5 hours going into the chair at the metal fabrication plant, and there's 0.6 going into the chair. That's how much time is spent manufacturing the chair at the assembly plant. And we can add these for the desk. It's 1.2, 0, and 0.9 for each one of those plants. And then for the storage unit, 0.7, 0.6, 0.5. So we've got those. What about demand? What is our demand here? The chair demand we're talking about one chair, right? We're saying this is the time that's going to be used for one chair. None of this. So we'll leave these blanks. This is the time that we're going to use for one desk. And this is the time we're going to use for one storage unit. And then over here is the total demand. So we're saying we don't want to make more than what demand is pulling, what the market's willing to purchase. And so for the chair demand, we have down here market demand for next month is 3,800 units. The desk demand is 2,500 units, and the modular storage units demand is 4,200 units. Okay, so we've got most of this blue filled out. This is a column of formulas, which formulas are down here for the same thing, just referencing that formula. This formula is going to take the sum product of the time and the number produced. This is going to give us a total number produced, right? So if we produced 5, just for demonstration purposes, if we produced 5 of each, this number is going to tell us how much total time it would take to make those 15 products, 5 of each, right? It would take, from the wood processing plant, it would take 9.5 hours. From the metal fabrication plant, it would take 5.5 hours. From the assembly plant, it would take a total of 10 hours. So we're saying a total of 25 hours of time that goes into making 5, 5, and 5. And the reason why we have to calculate total time is because we only have a certain amount of time for each plant. And so we can't go above that time. So these 3 constraints are dealing with the total number of hours in the plant and how much time we're taking up to making what we're making. So it's going to limit this based on the total limit of time. So let's calculate this total limit of time here. In this problem, this is saying 22 days a month, and they each work 8 hours a day. So we'll type in 22 days per month for each plant. And they each work 8 hours a day, so we'll type that in. What's different here is the number of workers. So we have a number of workers for each plant. The wood processing has 20, metal fabrication 18, assembly plant has 24. So these become the total amount of hours available that we can use to make these products. We can't go above that. So we have to set a limit to how much time we use to be less than or equal to these total limits here. We have to set a limit or a constraint to the total produced to be less than or equal to the total demand here. Pretty powerful, right? So we have these constraints based on how much resource we can use of time in the plant. We have these constraints based on market demand. We also have these profit inputs, these coefficients. And the question is, if we wanted to maximize this number, how many would we produce? I think we're ready for solver. I'm going to pull up my solver on the data tab. And there's solver. Again, if you don't have solver showing up on the data tab, that means that you need to add it in. When I click on solver, here is the solver parameters window. I'm going to set the objective cell to be the objective function value, which is G5 in my case. Again, this is that sum product that takes however many products we make times their profit for each one and adds them together. That's the sum product. So basically we're saying right now, if we only made 5 of each, our total profit would be just over $1,000. But to use solver, we're going to maximize that, given all these constraints. So we're going to set this up here. We're going to set our objective cell to G5. We're going to make sure that we've clicked on maximize option. And then we have the changing variable cells. I'm going to go ahead and select these 3 cells. These yellow cells are the ones that solver is going to change. It's going to go through thousands of iterations, maybe even hundreds of thousands, maybe even a million. I don't even know. Iterations to find out the optimal. What is the optimal number to produce to maximize this value? But we have these constraints. So if I were to take these out and just start from blank in my solver, I would click on Add. And I would just select all of these and say all of these individually have to be less than or equal to this number here. And I would click on OK, and that would fill my constraints window. I like to check to make sure that unconstrained variables are non-negative. That means we want positive values for our variables. We don't want any negative values. And then I want to make sure I'm using the solving method called simplex LP. LP stands for linear programming. And that has to do with the kind of mathematical models that it uses behind the scenes to find this answer. And without going into a ton of detail at this point, we can assume that we will be using linear programming, a linear relationship between the quantity and the profit, which isn't always the case, but generally that's true. Generally, that's more common a model to use than the nonlinear or the evolutionary. So I'll click on LP and we're ready to solve this. And it will do a whole bunch of calculations and it will beep and it will show you solver results. It should show you that solver has found a solution. All constraints and optimality conditions are satisfied. So it's saying, okay, I've met all the conditions you told me to do. Here's all the constraints, and we'll notice that each one of these is less than or equal to this value over here. And we have a total profit value of $465,000 if we make these amount of chairs, 3,583.33 chairs. It's okay to have 0.33 in here for now. There's other models that are a little bit more specific. But now we can just consider that like they started on a chair this week, and next week they'll finish the chair, right? So it's not a big not a big issue there. 2,500 desks and 0 storage units. How about that? So this model suggests that not producing any storage units will actually lead to the highest amount of profit. Yeah, I hope their customers are okay with that. But that's the model. And so we'll click OK to close this solver results window, and it will leave this solver answer here. And that is the solution to this homework problem. Let me know if this helps. We will see you soon. Thanks.